Hello everyone, welcome back to Ganit. Today we are going to finish exponents. There are 4 to 5 more type of questions which I want to talk about. And after that, what I'm planning to do is I want to create 2 to 3 separate playlists for two separate or three separate topics. Now, because we are entering the final exam season now, and it's not very far from here, so I just don't want to you guys to get stuck at one single topic for too long. So let's start with the remaining questions of exponents first, and then we will try and do the other topics. So the next question I want to talk about is, let me write the question first. It says 1 over 1 plus x to the power b minus a plus x to the power c minus a. Then plus 1 over 1 plus x to the power a minus b plus x to the power c minus b plus 1 over 1 plus x to the power b minus c and x to the power a minus c. And guys, please don't mind the background music, the BGM you keep on hearing, because I have a 3-year-old at home, so please don't mind for that. Okay, sometimes you might hear some noise. I don't know how to contain him, when it comes to that. So let's talk about this question. We have to prove this question. Okay, so this question, why I wanted to talk about particularly, there are negative exponents involved here. If you see, there is an x to the power b minus a, so there's a minus a, x to the power c minus a. So I will tell you how to understand the pattern of these questions and how you can approach in a simpler way so that you can avoid all the those small errors which teachers very fondly call it, silly mistakes. How you can avoid those silly mistakes, which are not so silly after all. I mean, you end up losing solid marks on that, right? So let's see. See, in such questions, what I try to do, I try to observe a pattern with one fraction, and then I try to replicate it on the second and the third fraction. Because if you notice, the terms do have a similarity. I mean, they do look very similar to each other, right? So I'm going to just expand the first term and see what I can observe from there. So in the denominator, see, numerator has a 1. I can't do much about that. But denominator has quite a few things to work on. So I can write x to the power b minus a as x to the power b by x to the power a, and x to the power c by x to the power a. I don't have to tell you, but I will still tell you, x to the power m minus n double-headed arrow blah blah blah. You already know the concept now. This can be written as x to the power m by x to the power n. So you know, we have seen it in previous videos how the exponent laws work both ways, and so does every other law in mathematics. So be careful on that, okay? Now if you take the LCM here, this becomes x to the power a plus x to the power b plus x to the power c, whole thing upon x to the power a. And don't forget, what you have is that there is a numerator which has 1. So I'm essentially talking about this. This is my expression, x power a, x to the power b, x to the power c over x to the power a. Now when you have 1 over something, for example, if I say what is 1 by 2 by 3, it's nothing but 3 by 2. 1 by of anything is nothing but a simple reciprocal of whatever fraction you're dealing with. It can be a fraction, it can be a number too, but 1 by anything is the reciprocal of it. So what we will essentially get here is x to the power a by x to the power a, x to the power b, x to the power c. Now, I'm going to explain you a very important point. Kindly pay attention. If you notice, I'm going to show you how to observe the pattern now. So if you notice here, we have a x to the power a in denominator, x to the power a in denominator. So both the terms had b minus a and c minus a as my exponents, correct? But minus was applicable to a only. So if you notice, the a had a minus sign in both the terms, right? That means if I come from here to all the way here, you will notice that the term which was in denominator, it eventually went to the numerator, and x to the power a plus b plus c stayed in the denominator. So something similar will happen. You can follow the same approach, and where you will land is x to the power b by x to the power a plus x to the power b plus x to the power c. Let me explain how I got x to the power b in top. It's exactly the same reason by which I got x to the power a on top. So if you notice here, x to the power a was in denominator. X to the power c minus a, x to the power b minus a. What is it here that you observe? X to the power a minus b, x to the power c minus b. So minus sign is with b this time. So as a result, x to the power b will come on top. Similarly, we'll have x to the power c by x to the power a, x to the power b, and x to the power c. So if you simplify this further, what you essentially have is same numerator and same denominator, which is nothing but 1. Now, I want to talk about something in general too. So this question is done, by the way. Now, in exponents, a lot of times you will have questions which will ask you to, reduce a big, massive looking equation to 1. So you'll have to do whatever tricks you can apply, simplify it, and eventually reduce everything to 1. Remember, guys, 1 can be obtained in 2 possible ways. Okay, pay attention. Okay, very important. So how can you observe, how can you get 1? You can either get 1 if you have something like a by a. That means if you have a same numerator and same denominator, they will cancel out and give you 1. So that is one way to approach it. Or in terms of exponent, you could get an x to the power 0. So anything to the power 0 is 1, but there is no third possibility. So if you are dealing with exponents and you are dealing with fractions, possibility of creating a 1 as your final result exists in these two things. A by a, meaning same thing in numerator and denominator, or something raised to the power 0. So remember, when a question says prove that this is equals to 1, you should know what you are chasing. Either you are trying to create same numerator and denominator, or you are trying to make all the exponents add and subtract and cancel out and become 0. You would have seen that in the previous questions that I had explained. There were questions where all the exponents eventually got cancelled and everything became 0. So we eventually had x to the power 0 and it reduced to 1. Now, let's move on to the next question. So we have now this is a very important question I wanted to talk about. So we have 3 by 5 to the power root 3 by 5 to the power x minus 1, and I have a 27 to the by 125 to the power minus 1. Now every one of you, each one of you would think that if I have a negative exponent, sir only told in one of the videos that you should change it to positive exponent. That's the first step you should take. Well, I said that. I mean, I stand by it completely. So what you can do is you can write this as 125 by 27, and then it just becomes power 1, right? Minus 1 changes to plus 1. You don't need to write plus 1. But what you have to notice is, in my previous videos also I have explained this theory. We can't have composite numbers. I had clearly told they are red flags. What we need to solve a question is green flags. So 125 by 27 is a walking red flag, guys. They're composite numbers. What we need to do is we'll break them down into prime numbers. So 125 can be written as 5 by 3 to the power 3. If you see here, I have a 3 by 5 to the power x minus 1. Now, this kind of question where you have to find the value of x, it works on two very simple concepts. First, you need same bases on left and right hand side. 3 by 5 and 5 by 3 are not the same bases. You may say the numbers are same, but the bases, no. 3 by 5 and 5 by 3 are not the same numbers. So, what you have to do is you have to make the bases same. And once you have achieved that, then comes the second part. You can get rid of the exponents. You can get rid of the bases and equate the exponents. Now, root 3 by 5 can be written as 3 by 5 to the power 1 by 2. And then this whole thing is to the power x minus 1. That means it can be written as 3 by 5 to the power x minus 1 whole upon 2. Now, there are two rules I used here. First is x to the power 1 by a is nothing but 8th root of x. We have seen that. That's a law. That's a law of exponent. The second law what I used was x to the power minus a can be written as 1 by x to the power a. So these are the two things which I have used in this question. Okay. So now I'm going to use this something similar. So 5 by 3 was carrying all along with an exponent 3. But I want 3 by 5, so I'm going to write it as minus 3. So this is where the game changes. If you notice, I had a 5 by 3 on the right hand side. But 5 by 3 does not help me because it's a different base. I need 3 by 5. I had explained you earlier also. So what we will do, now we have reached a stage where the second point will kick off. Once your bases are same, you can just equate the exponent. So what you will get, x minus 1 by 2 is equals to minus 3. That means x minus 1 is equals to minus 6. You cross multiply, the 2 goes and multiplies with the 3. And that means you can write x is equals to 1 minus 6, which is negative 5. So the final answer is x to the power minus 5. I hope you all understood the questions. You have to understand two important steps, three actually. No composite numbers. If you have composite, make it prime. Second, same bases. So if your bases are even a bit different from each other, make them same. Okay. And third point, once your bases are same, equate the exponents. All right. Now let's move to the next type of question. This question that I'm going to explain, the last two questions are going to be a little bit special. They are different questions. They are questions which you have not, if you have never solved it before, it might be a problem. You know, it might not be a good option to directly face it in the exam. So if you are dealing with questions which you have practiced at home before, it just helps you. All right. Now, let's see what this question is all about. So the question says, if ABC is equals to 1, we have to prove that 1 upon 1 plus a plus b to the power minus 1 plus 1 upon 1 plus b plus c to the power minus 1 plus 1 upon 1 plus c plus a to the power negative 1, and that is all equals to 1. So the basic fundamental involved here is, in a nutshell, if you look at it, it's again asking you to prove equals to 1. That means you got to have numerator and denominator as same numbers, or you got to have the exponent as 0. The exponent becoming a 0 looks very difficult here because we don't have same terms, we don't have similar looking exponents, everything is quite different from each other. That will not work here. So what you have to understand is, in this question, what's so special about this question? The information given to you, ABC is equals to 1, that gives you a lot of information. You know how? You can write A B as 1 by C, you can write B C as 1 by A, and you can write C A as 1 by B. But not yet. See here, can I write 1 by C as C to the power minus 1? Can I write 1 by A as A to the power minus 1? And can I write B as B to the power minus 1? If you notice, B to the power minus 1, A to the power minus 1, and C to the power minus 1, they are all present in the question. That's exactly why I'm telling you that why 1 by C can also be written as C to the power minus 1. Okay, so I hope you understand what I'm saying. And remember, what we are chasing is numerator and denominator as same terms. So what we're going to do, in the first fraction, we're going to replace 1 in the numerator with ABC and the denominator with ABC. So A and the B to the power minus 1, if you see here, is nothing but AC. Now ABC over A can be taken out common, BC plus 1 plus C, and A cancels out. What do I have? BC over 1 plus C plus BC. Now, if you remember what we just talked about, we want something upon something. We want same numerator and same denominator. That's what we are chasing. If you notice here, the denominator has 1 C and BC. The numerator already has a BC. So what are we after now? What are we chasing now? We are chasing a 1 and a C in the numerator. The moment we get that, our job is done. So let's see what we can do with the second fraction. So second fraction, now you would want to replace 1 with ABC, because I just replaced 1 with ABC in the first fraction. It only makes sense, right? But it doesn't. It doesn't. You replace 1 with ABC again, you are going to round up to the same result. Remember, you are chasing three separate terms, 1, C and BC. BC you have already found, you still have to find 1 and C. So if you still again replace 1 with ABC, aren't you going to end up with again BC or something like that? So we'll not do that. This time around, what we will do, we'll write 1 plus B, and we will not replace C to the power minus 1 with AB. What we are going to do is, because when we write with the AB, when we replace it with AB, the problem happens here. You will write a AB here, then you would want to replace this with ABC, and then you will say B is common this time, so BB will cancel, right? But in the numerator, this time AC will remain, and we don't want that. So please do not do this. You cannot write AB. Let it be C inverse, which is 1 by C. Now if you take the LCM in the denominator itself, this becomes C plus BC plus 1 whole upon C, which is eventually C over 1 plus BC plus C. If you again pay attention, what I did was I made the denominator same. So this whole calculation was involved in the denominator. I was taking LCM and simplifying. But when I saw that there is a C, BC and 1, I immediately thought of my first term. My denominator was 1 plus C plus BC. And I found 1 plus C plus BC in my second fraction also. And to top it off, the icing on the cake, I had a C in my numerator. That is gold dust. So I am chasing 1, C and BC. Now I have BC and C. What remains is 1. So let's see. The third one, I don't even need to do anything. There is 1, there is C already present. What do we need? BC. And guess what? A to the power minus 1 is BC. So I'm just going to replace it with BC. So eventually, my third fraction became 1 plus C plus BC. Now, if you look, I have the same numerator and the same denominator, which means that this whole thing is equals to 1. So I hope you're getting what I'm trying to suggest in these proving questions. When we are chasing a 1, it has to be either raised to the power 0 or same numerator upon same denominator. Very important question, guys. It can very well be asked in your exam. ABC is equals to 1 can be replaced by XYZ is equals to 1, PQR is equals to 1, and whatnot. But understand the concept lying behind the question. All right. Let's move to the last question on exponents, and then we will start with a new topic altogether. So this question is something that I had mentioned also in the last class. I had talked about it. Let me write it first. So the question says 2 to the power x is equals to 3 to the power y is equals to 12 to the power z. I think by now you have guessed it what this question is all about. 1 by z is equals to 1 by y plus 2 by x. So remember, if you remember, I had told you in the last class, in the last few videos, that whenever you have three things equal to each other, what you do? You complicate the situation. You mess it up even more. What you do? You bring another fourth variable, because we are not satiated. We are not happy with 3 variables. We want more, right? So what we are going to do? 2 to the power x, 3 to the power y, 12 to the power z is equals to k. Right? Now, I'm going to individually equate them. So 2 to the power x equals to k gives me 2 is equals to k to the power 1 by x. I will again explain it. Remember, 3 square is 9, but 3 is 9 to the power 1 by 2. So when your exponent moves from left to right, in an exponent position, it flips. It becomes 1 by. So we have 2 is equals to k to the power 1 by x. We have, similarly, we will have 3 is equals to k to the power 1 by y, and we will have 12 is equals to k to the power 1 by z. But the earlier question that we had done had a relationship given to us, b square is equals to ac or something. Okay, that was given to us. Since we are dealing with numbers now, there is no relation given. But we are smart. We know 2, 3 and 12 have a relation. How so? If you write 2 into 2 into 3, what do you get? Guess what? You'll get 12. So that means 2 means k to the power 1 by x. Another 2 means k to the power 1 by x. 3 means k to the power 1 by y, and 12 means k to the power 1 by z. If you notice, k, everything is equal. All the bases are equal. What do we do in such cases? We will add the exponent. So 1 by x plus 1 by x plus 1 by y is equals to k to the power 1 over z. That means k to the power 2 over x plus 1 over y is equals to k to the power 1 over z. That means 2 by x plus 1 by y is equals to 1 by z. And that's your final proving statement. I hope Exponents is clear to you. I have tried my best to explain every single concept. I will provide you with a link on which you can share your doubts, ask your questions. I will also provide you with some more practice questions so that you can practice at home. For now, we will close the session on Exponents. The next thing that we are going to do is the basic concepts of circles and trigonometry. All right. Till then, see you guys. I hope you enjoyed the session.